So, good afternoon here in the UK, good night in Australia, and good morning in the United States. And welcome to this GHIF Forum, the Genomics in Health Implementation Forum. And I'd like to welcome you on behalf of Catherine North and myself. And we'll just start off with a brief introduction for everybody and then take it from there. Can I just check, Lindsay, that you can hear me?
Yep, I can hear you. Thanks, Mark.
Grand, thanks. So without further ado, the Genomics in Health Implementation Forum was born out of the National Initiatives meeting of the Global Alliance for Genomic Health, which we're all here to champion. And the fundamental precepts on which this is constructed is that we will gain by collective learning, by attending events like this, but in between times by how we work together, how we collaborate, how we share resources, and how we use resources and bring our collected expertise as the global community together for global data sharing. So let's move to the next slide. So we've had a series of meetings which started focused initially on national initiatives, but have now coalesced around this major step change, which is the Genomics in Health Implementation Forum. And that formalization has allowed us to begin to look at how we are working together to incept and transfer standards across the globe. So the purpose of today is to showcase the work that's been done, also introduce some of the newer national initiatives and what they're doing to adopt standards, but also to essentially be a rallying call to all of us to join in and commit to making the healthcare implementation of genomics worldwide smoother, better, more efficient, and with the most patient benefit. And so, just trying to move it on, actually. It doesn't seem to move on anymore. Okay.
Down everyone. Yeah.
Thanks. So from national initiatives to this forum, the why, well, this is a way of taking us from discussing our own national initiatives to a collaborative framework that fits needs across multiple initiatives in healthcare systems and can increase a global membership and involvement in GA4GH by encouraging diverse input that perhaps might not normally get involved in standard setting, but actually is crucial to scale these things across the world, and in particular to make sure that there's the collected learnings that are applied for further development in the GA4GH work streams. So this community is about taking the standards, implementing them, developing them, and making sure that they're fit for purpose. So if I summarize the ecosystem, there are over 600 organizational members, 90 countries, 3,000 subscribers, 24 driver projects, and 8 work streams, 20 technical standards in development, 7 regulatory policies and frameworks, and 40 plus implementations and deployments. And in essence, this enables, in the GA4GH ecosystem, a global learning health system. And it's designed for us to be able to cherry pick the projects which we'll work together on and to make sure that these maximize benefits across the world. So this is really the fundamental at the heart of this. It starts with a patient or a research participant and moves through the usual process to engage in research with a centralized data set that is brought to life and mobilized into healthcare by using data commons and standards that we share, develop here, co-own, co-solve, and bring into clinical practice. And so this continuum is what we want to get to through the GHIF Forum. So on the left are driver projects, but if we move to the right, the Global Health Implementation Forum has 2 chairs, Catherine and myself, and this provides the forum for national initiatives and those involved in those initiatives to form partnerships that can allow with other members, the GA4GH community, to begin in or develop 2-way dialogue with that international community, including focus on national initiatives, and leading to further partner engagement in those driver projects. And so this is how we fit with GA4GH. In essence, the group that assembles here are about implementing those standards and making sure that they're fit for purpose, working with the driver projects. And here you see the current Global Health Implementation Forum members, with two founder members, Australian Genomics and Genomics England, but everyone here is equal in their contribution that they can make in what they can do to change the worldwide application of genomics. So becoming a GIF member, there's a short, easy process to do that, and we would welcome anyone who has joined us here today from a national initiative who would wish to be involved in this. You're part of this community, so please do engage. There's a slight delay on the slide transition. I apologize for that. Okay, so benefits of this being a member here are global learning, contribution to GA4GH standards, access to the tools that are developed within this collaborative, and the potential for you to collaborate and bring your skill sets, knowledge, and intellect to bear through a range of pilot projects. And so I'm going to hand over now to Catherine to run the slides and to share with you about information about the toolbox. Over to you, Catherine.
Great, thank you, Mark, and welcome to everyone. And I would urge you, I think before this meeting, we sent around to all of the registrants. There's a link that gives you a short sort of half-hour video that gives you an overview of all the activities of the Global Alliance. And there's also a copy of the membership form in terms of joining into GIF. And what we're really aiming to do is to pool our expertise internationally. Part of what we're establishing at the moment is a toolbox that not only is bringing into place so that you can easily access them and apply them, the Global Alliance standards, but also tools that we're bringing in from around the country, around the world now, in terms of consent forms so that you can see what others have done in their countries, health economic data to help you make the case to your governments about the benefits of genomic medicine, clinical tools, experience around media and engagement, particularly public engagement, as well as a repository of technical and data tools and genomic knowledge tools. So the toolbox is under construction, and there are, what you'll find at the moment, it's currently on a Google Drive, where there's various subheadings where we're collecting data from all the national initiatives that have been involved and will be into the future. For example, there's a series of consent and education tools that you can access, and very valuable educational material, as well as different consent clauses that you can basically cut and paste to use locally. There are also clinical tools, and these are particularly useful, bringing in from different countries where they've developed minimal clinical data sets required for, say, epilepsy or cardiomyopathy, that are actually what are the minimal clinical symptoms and signs that you need to collect and the investigations that you need to record that are going to optimize the interpretation of the genome at the laboratory basis. What will also soon become available is a tool that's been developed using FHIR and integrating with REDCap, so that we can move from the hand-drawn pedigrees into a machine-readable pedigree that's easily implementable locally. So the Genomics and Health Implementation Forum, our original plan in 2020 was gathering together in Frankfurt, and then we're all about to welcome you to Melbourne in Australia. And then of course, COVID happened. So we've moved this year to virtual meetings, and we had a very successful one in March. And it's really great to see we've have over 280 registrants across multiple countries to this meeting. At the virtual meeting in March, and this demonstrates sort of the range of countries involved, we also did a survey of all of the different initiatives at a major national level and looked at the areas of focus. And as you can see here, we're seeing trends that there's moving from exome sequencing into whole genome sequencing. And also a big focus initially, as we would expect, on rare disease and cancer. But everyone is also facing the challenge of setting up the infrastructure by which we can acquire and store, analyse and utilise both genomic and clinical data. And this is the type of expertise that we're now sharing. This meeting now has, this is showing the representation across the world, and as I mentioned, 280 registrants. And the goal of what we're going to do here is to demonstrate some of the pilot projects that we've been running around really important areas such as curation, the acquisition of clinical data, regulatory and ethics concerns, so that you can get a flavour of the type of work that we've been doing. But where we want to go after this meeting is to engage with you on a more regular basis. Certainly we're doing this virtually at the moment, and hopefully we'll get to some face-to-face meetings towards the end of 2021. But we'd also encourage you, as well as joining up and really looking at the tools that we have available, to start to participate in the pilot projects, because that's really, we've found the best way to be implementing genomic standards and using the resources within our own initiatives. So we've got quite a rich agenda, which we're going to move on to now, and that are going to cover in this first day around curation, the consent and return of results, and clinical data capture. And then we'll reconvene tomorrow for a complementary session. Please use the Q&A at the bottom of the screen for questions that you have. And I'm now going to hand over to Augusto Rendon to kick off chairing the curation session.
Great, thank you, Catherine. Can I just confirm that people can hear me? Oops, that's not me.
Yep, we can hear you.
Okay, let me share the right camera. There we go. Great. Hello, everyone. It's a pleasure to help steer us through this curation session. I think we often think about fancy algorithms and things to deliver genomic health care to patients. But I think it's true to say that still in the lab, we do this by really doing curation, sharing data, and being very careful about what we think we can get a report from. So the session today is precisely about big endeavors along these lines to try to get us to important data sets to get us going with curation. So why don't we get started? Our first speaker, yeah, great, thanks. Go for it, Trinity. Can't hear you.
I think it's Marina.
Yeah,
Marina.
yes. Sorry, I was just requesting remote control. Can you guys hear me now?
Yes.
Yes.
Great. Hello, everyone. So I'm just going to give you a brief flavor about the GenCC, which stands for the Gene Curation Coalition. Zornitza and I will tag team. I'll talk about the overall organization, and then Zornitza will talk about the collaboration of PanelApp within GenCC. So GenCC is made up of a bunch of different international curation groups, and these are some of the original members and just brief little summaries of their curation work. And today I'll be talking about curation of gene disease validity. And when I say gene disease validity, I'm asking the question, is that gene associated with that disease? And performing the curation to find out. So most of the time it's a gene, a disease, and a mode of inheritance, and asking the question, is that gene associated with that disease? And so these were the original members that came together a few years ago as the GenCC. As we made our way through standardization projects, we did end up adding additional members, particularly in industry. And these are listed here. And these are a few goals of the GenCC. In the very beginning, we wanted to understand all of our curation efforts. So we really wanted to clarify the overlap between the gene curation efforts. And in order to do this, we needed to understand the aims, processes, information used, classification systems, and users of the different curation efforts. So we spent a bit of time kind of getting to know each other. After this, we worked to develop consistent terminology for validity assessment, which I'll talk to you about in following slides. We're now working also to determine consistent terminology for inheritance, allelic requirement, and mechanism of disease. And then eventually with the goal of collaborating on gene curation projects, and I'll speak at the very end a little bit towards that, and Zornitza will talk about that too. So in order to harmonize clinical validity terms, or each term we use to describe the amount of evidence that exists for a gene-disease relationship, we performed a Delphi survey. So we drafted harmonized definitions for gene curation categories. And in the Delphi survey method, we also solicited term suggestions from the GenCC members to draft the Delphi survey. We then performed 3 rounds of the survey. The first one was just with the GenCC members, 33 members there that took that survey. The second one extended it to the curators or additional members of the GenCC groups. And that was 38 people who took that survey. And then finally, with an optional explanatory video, we surveyed the genetics community internationally, and we had 241 responses. The overall preferred term set that we ended up with is here on the right. Definitive, strong, moderate, limited, disputed evidence, refuted evidence, animal model only for those that only have animal models, and no known disease relationship. And this was important because we decided to use this preferred term set for our website, which I'll talk about. So we wanted to be able to really leverage the curation data that had been done by all of our different GenCC members. And so we wanted to put together a website that essentially displays all of this data a la a ClinVar for gene curation. And these are just a flavor of all of the pieces of information that we hope to display very soon on this website. 25,000 OMIM entries, over 1,000 classifications from ClinGen, over 12,000 gene disease relationships from Genomics England's panel app, about 7,400 curations from Orphanet, over 5,000 curations from Ambry Genetics, 14,000 gene disease pairs curated by Invitae, and about 4,000 gene disease relationships from the Panel App Australia. So a great amount of information that hopefully will be of great help to the community. And this is just a screenshot. So we have soft released our website right now, www.thegencc.org. However, it doesn't have any of the gene curation data live yet. It just has overviews of our Delphi survey, a couple of the abstracts that we've presented at the American College for Medical Genetics meeting, the International Society for Biocuration. It talks a little bit about the steering committee and summary paragraphs about all of the GenCC member groups that I just detailed to you in the previous pages. So feel free to go and take a look. However, we will release the actual curation data hopefully in the next coming months as a beta release and then eventually as a final release. And this is just a screenshot of the website here. This is not actual data. This is just a mock-up, but it presents pretty much the entire list of genes on the main page, and you're able to click open to each gene to see the disease equivalents, who submitted on it, much like ClinVar, and then you see the overall summary statistics for each gene of the clinical validity buckets of the Delphi survey terms that I just mentioned that we had harmonized to. And then if you click into each gene, if you were to just click on that gene, you can go to a detailed summary page that will either have the classifications listed by disease, mapped using the Monarch disease ontology, or by submitter, kind of how it is here, and also by strength of clinical validity. So definitive being the strongest listed on top, strong, moderate, and so on. And we are hoping in the future to be able to actually create a panel building app where you can use the Monarch disease ontology to search certain diseases within the tree and create a panel that you can then download and use within your work. And so stay tuned for this website coming soon. And with that, I will pass it over to you to Zornitsa, and I will control the slides for you.
Thanks, Marina. So I'm just going to give an example of this type of work. So this is based on the joint work that we have been engaged with Genomics England over the past 9 months. So Panel App is an open platform for recording gene disease validity assessment and managing virtual panels. Next slide, please. So it was originally developed for the 100,000 Genomes project by Genomics England, and more recently has been used to establish consensus panels for the NHS Genomic Medicine Service. Genomics England very kindly made the software open source. Thank you, Augusto, and Australian Genomics deployed the platform locally at the end of last year. So huge thanks to Oliver Hoffman and his team. Since then, we have been uploading panels basically from our Excel spreadsheets onto the platform, and the Panel App Australia platform contains panels used by Australian Genomics projects, Melbourne Genomics projects, and a number of diagnostic laboratories. Next slide. So we're already at an advantage in that between the two Panel App instances, we are basically using the same rules for gene disease validity assessment, so we don't need to harmonize any of that. And also the gene disease validity assessments are captured in the same format. But we have retained our own governance so that we can basically disagree with each other if we wish. Next slide. Having the same platform and harmonized terminology, though, has made it very easy for us to compare our gene disease validity assessments fairly quickly just by importing panels from one instance into the other. There's a very nice functionality on the platform that allows you to compare panels and identify discrepancies very quickly. So we have almost completed the process of comparing all the diagnostic panels that we have in common, which is over 70, and within those panels, we have identified now just over 2,000 discordant gene disease pairs. So we've gone through an exercise of reassessing the evidence for gene disease validity for those discordant pairs, and have exchanged a number of reviews to suggest that certain panels should be included or excluded from diagnostic panels. We have also set up a process for combined literature review every month, and we're adding 30 new gene disease associations on average through that. So we've seen a huge benefit from this process. Basically, the more genes are promoted to diagnostic grade, that means more diagnosis for our patients. For the genes that don't have solid gene disease validity, they can be removed, and that improves the efficiency of the diagnostic process. And this has been a fantastic exercise also to engage a broad range of clinicians and diagnostic laboratory personnel in training up in gene disease curation. Next slide. And back to you, Marina.
And with that, we just wanted to acknowledge the members of the GenCC. I know that they've spent a lot of time doing this curation work and working together with us and harmonizing these terms. So they are listed here.
And if anyone else has got gene disease curation efforts and would like to join, please get in touch.
Yeah, please do reach out.
Great. That was phenomenal. Thank you so much. Just to clarify, Lindsay, could you let us know the asking questions? Do you want us to use the Q&A? Do you want us to raise a hand?
Yeah, no, thanks, Augusto. So people can either put the question in the question and answer box at the bottom of your screen, or if you'd like to make a verbal comment or question, you can just use the raise hand function and one of us will unmute you. So either or is fine.
Okay. And so let's keep questions for the end of the session, but just people can raise them as we go, and then we can come back to the various presenters. All right, so why don't we go next, please? Great, thank you, Melissa.
Hello, everyone. Am I unmuted now?
Yep, we can hear you.
Great. Thank you. I'm Melissa Landrum. I'm the team lead for the ClinVar database at NCBI, and I just want to thank the organizers of this meeting today, for giving me this time to talk to you about the work that we're doing to develop an API for submission to ClinVar. So I think most of you are probably already familiar with ClinVar. This is NCBI's database of genetic variants and interpretations of how those variants relate to disease. So today the database holds more than 1.3 million submitted records, which represent 844,000 unique variants. And this data has been submitted to ClinVar by more than 1,600 organizations across the world. So the ClinVar team is really delighted to see that ClinVar has become a global resource, and we're also interested in extending that globalization, both in terms of the volume and the genetic diversity of the data. So although the data in ClinVar has come from many different groups across the world, the majority of the data actually comes from some of the clinical testing laboratories. So you can see here, I'm showing a list of the groups who have submitted the most data to ClinVar. You can find the full list of all of our submitters online. But you can see there are some submitters who are really submitting to ClinVar in high volume. And one thing that we have found in the last few years is that the volume of data that's being submitted now is actually sort of outpacing the processing that we had put in place when we first developed ClinVar. So we have had some issues and feedback from submitters that we need to publish data faster. So that is something that we've been working on for about the last year, and we're continuing to think about. Over the last several years, we've also had several of our submitters, particularly the same groups with high volumes, expressed interest in a more automated way to submit. So right now, any batch submissions that come to ClinVar come through a file, and that's typically an Excel spreadsheet that has to be manually uploaded to our submission portal. So several of our submitters have been looking for something that's much more automated, requires no manual touch on their end, and also no gathering data into a file. So with those two pieces of stakeholder feedback, faster turnaround times, and also a more automated method to submit data to ClinVar, we have started development on an API for submission. So you'll notice on this slide, I have this work in progress graphic. This is on this slide and all of the following slides to remind you, this is very much a work in progress. It's in active development right now. So what I'm going to tell you today is really a status update. I expect the big picture to be the same by the time we get to our first release, but some of the details may have changed. So please do keep that in mind. So we are developing a REST API. It will have one endpoint for you to use to submit data. That data will come to us in JSON format. In the first release, the API will support submission of one record at a time, and that record can either be a novel record to the database or an update to an existing record. We will authenticate the submitter, as we do for all of our other submissions. And one difference for the API is that these records will be processed entirely automated on our end as well. So there will be no touches from a curator, no review from a curator on our end. We think that will help with faster turnaround times. And so for this first call, when you submit your data, you will get an immediate response, and that will include a submission ID. And it will also include a status, and this will be just like a high level status to let you know either that we've received your data or that there's an error, and it will be just a basic type of error like your JSON is in invalid format or our services are down. There will be content validation, but that will happen in a later step, and I'll talk about that in a minute. So the first release of the API will support a subset of all the fields that you can submit to ClinVar. So of course it will support the minimal fields that we ask for in a ClinVar submission, shown here on the left. We will also support a small subset of the optional fields. And this particular set of fields was chosen because these are fields that are routinely submitted by the laboratories who currently submit to ClinVar and who have expressed interest in an API. So we're interested in supporting those groups who are already submitting, would like to use this, this submission route. But of course, we can always add more features in the future as needs change. So this is just an example of what we think the JSON submission will look like. So the first section here is some general information about your submission, who you are, statuses, your assertion criteria. This next big section is for the interpretation itself. So there's the value of the interpretation, the date you last evaluated it, a comment or a citation about that interpretation or clinical significance, the mode of inheritance, the observation data, and then if you were to scroll down, you would also see there's a description of the variant and of the condition for the interpretation. In this example, you can see the variant is described with HGVS. You could also describe it using chromosome coordinates, so say start, stop, ref, alt, or start, stop, and a variant type for a copy number variant. And similarly, for the condition here, we're showing a database identifier for the condition, but you could also provide a name instead if there's no identifier for your condition. So I told you earlier, when you first submit your data to us, you will get back an immediate response letting you know that it's received, and then we will start content validation. And we're doing it this way because content validation takes a little bit more time, and we want to be able to give you an immediate response that we've received your data. So once we have the validation starts, it's the same validation as we do for the other routes of submission. So as a submitter, you should have a very consistent experience no matter how you submit to ClinVar. And as a user, you should know that you're going to see a consistent set of data across the database. So we validate all of the minimal fields that I mentioned earlier. We also check for duplicate records. So this typically happens if a submitter gives us the same variant and condition, calling it a novel record, but they meant to call it update. And then for updated records, we also check for changes to the variant description, the local ID and linking ID. These are internal identifiers used by some of our submitters, and we're expecting all of these information to be stable across updates. And so the way that you, as a submitter, will get back the information from that validation is to do a status check. So we will have a second endpoint that lets you request the status of your submission, and you'll use that submission ID that we gave to you in response to your first call of the API. So when you do the status check, the response will include the status itself. We haven't worked on this part of the development yet. We think the statuses will be a very simple set. So something like queued, processing, success, error, and public. But that could change as we get into it and see what works. We'll also give you back the date and time of your request, your local and linking ID if you use those in a submission. And we will return your SCV accession number for your submission. For novel records, we can give that to you once that record has passed validation and been loaded to our production server. So in terms of the status, that will probably be either success or public. And we can always return the SCV accession number for an updated record because it's already been assigned. And importantly, this is where you will get the error messages from the content validation. So for example, we can tell you, we've rejected this submission because your HGVS is invalid. So for our future work, the immediate work, of course, is to finish the development and make our first release of the API. But once it's out, we'll first be engaging our customers, both working with current submitters on adoption of the API. We know of several groups who'd like to use it. We'll help onboard those groups into using the API. We're also interested in talking with both users and submitters to see how they react to data that has been processed entirely automatically. As I mentioned earlier, this data will go through with no review by the curation staff. So we want to make sure that although we're increasing the speed of submissions, we don't want to really hurt the quality of the data that you see in ClinVar. And then presuming that the API is successful, people enjoy using it as a way to submit, we'll think about ways that we can improve it. So we think there's a lot of opportunities for adding other sorts of data to submit through the API. For example, we can add more fields that are related to the interpretation of variants relative to a drug response. We can also add support for interpretations of combinations of variants as haplotypes or genotypes. I mentioned earlier, the first release of the API will only support submission of single records. So if you have 100 variants to submit, you'll call the API 100 times. But we'll also look into the possibility of providing batch submission. We know this is of interest of some of our submitters, and we think this will gain us some efficiencies in processing as well. And we also think that this feature may be of interest to some software companies who want to allow their customers to submit to ClinVar while they're using their software. So we can also look into making the API support submission on behalf of another organization. And so to close, I just would like to thank the ClinVar team who works very hard to make ClinVar available to the clinical genetics community. This is our team of developers on the left and our team of curators. And I also like to thank our leadership at the National Center for Biotechnology Information and the National Library of Medicine. And finally, if you ever have questions, comments, suggestions for us about ClinVar, about the API, what I've talked about today, or anything else, I'd encourage you to contact us with your feedback. You can contact me directly. My address is here. You can also contact the team, ClinVar at NCBI. We'd love to get your feedback. We're always interested to know how we can make ClinVar better. And so with that, I'll close. If we have time for questions, that's great. Otherwise, we can wait and start the discussion.
Thank you so much for that, Melissa. What I would say is, if you look in the question and answer, there are currently 4 questions around your presentation. I would suggest that if you can answer them directly there, and if there are any remaining questions after that, then at the end of the session, we will just speak to all panelists. So you can say, type the answer in the Q&A, and there are questions that to some extent were already answered during your talk, but it'd be great to have that confirmation from you that that's indeed what's happening. And then we'll come back at the end if there are any large outstanding questions. I hope that's not too convoluted. Good. So can we move on to the next presentation, please?
Alyssa, you're still controlling my screen here. Would you be able to? There we go. Thank you.
Great. Thank you. All right. So let us hear from Big Med in Norway that, great, thank you very much. And just to remind people, there is a Q&A button at the bottom of the screen. There questions are there. You can see also which ones have been answered and what the answer was. So I encourage panelists to start typing answers and others to put them in there. Thank you very much. Let's get on.
All right, so hi everyone. I'm Martin Eike. Thank you for this opportunity. I will give a brief introduction to Big Med, which is a lighthouse project funded by the Norwegian Research Council, and is a consortium of 20 partners from academia, industry, and the clinic. It is the largest public precision medicine initiative in Norway at the moment, and our goal is to lay the foundation for a clinical implementation of precision medicine. This we do by working to eliminate barriers as well as develop tools, and we will present 2 of those tools here. So first, Ella, for which I am the product manager. Ella is a variant interpretation software we have been developing at the Oslo University Hospital. It is a tool very much focused on rich documentation of variant interpretations, and I think to a larger degree than most other general analysis tools out there. Our goal is to structure as much as possible of the documentation, including manual input, and everything is based on the ACMG AMP guidelines. We also put a lot of weight on standardizing workflows to reduce inter-interpreter variation with predefined filters and steps rather than leaving it up to the individual interpreter, as well as encouraging independent review of all clinically relevant findings. Another goal of ours is to come to a conclusion as fast as possible, so we've implemented a number of efficient customizable filters, as well as tagging to highlight particularly useful pieces of information. Ella has from the start been developed in close collaboration with interpreters who have become quite invested and eager to contribute to further improvement. It is well established. It's been in production at our Department of Medical Genetics in Oslo for 2.5 years, and is currently also being implemented at St. Olavs Hospital in Trondheim. And it's open source. We are very interested in collaboration, so please feel free to contact us at our website, allele.es, where you also find further information and some screenshots of the software. As for data sharing, we have a long-standing goal of adhering to GH standards and are eagerly following the developments. Sharing of genetic data in Norway has long been hindered by strict regulations, but DNVGL's work with the trusted variant exchange up next could very well solve many of our problems. So over to you, Steve.
Thank you, Morten, and good morning, afternoon, and evening to everyone else. My name's Stephen McAdam. I work for DNVGL. It's an international company that's been around for 150 years and globally present and owned by a foundation with the purpose of safeguarding life, property, and the environment. And what I wanted to just explain in the next 2 minutes was the work we've been doing, both within BigMed, but also the Nordic Alliance for Clinical Genetics, to develop quite a simple tool for sharing of variants. It started in the initiative started when we were involved in the initial meetings between the partners that later became the Nordic Alliance, where it was clear that partners had a desperate need to share variant data. They weren't doing that, and they're still not doing that. Obviously, everyone has the ambition to be publishing on ClinVar or other open databases. But working within BigMed, we were able to really try and understand what the needs were and why that wasn't happening at the moment. I don't think I need to explain to this audience that there's a real drive in terms of quality assurance of the interpretation of the variants, and this is linked to patient safety. But as Morten mentioned, there are a number of different reasons, including legal questions that still haven't really been resolved in certainly in Norway, but also some of the other Nordic countries, that mean that the laboratories really want to be able to control who they're sharing with the variant data, especially when it's ongoing work and development work in the clinic. And they wanted to be able to decide who they shared their variants with, but in a secure area and a secure way. So it's a little paradoxical that we have developed a secure system for sharing what's essentially anonymous variants, and the whole system has been designed to ensure that this is only anonymous data. The system's very simple. Of course, in addition to being able to search for variants amongst your partner organizations, to upload both in batches and singly, the system also will identify automatic discordances between partners if they've identified variants and classified them differently. It will also goes down to the level of the classification criteria to show why that may be the case. It's as I say, it's a simple system. It's delivered through SaaS. We have both APIs that allow those laboratories that have more sophisticated IT infrastructures to use that kind of automatic system and link it into their production system. But there's also the facility to enter things in manually and search manually through a graphical user interface. We've now tested this with laboratories in Denmark, and we're now starting through the Nordic Alliance to start benchmarking in the next few months between countries, and it's going to be interesting to see what results that gives. We're always open for feedback and thoughts about what we've developed. and also open to new users. And it's very welcoming to see that ClinVar now is developing the API for submission, because one of the main goals from all the partners, I think, is to get the confidence in their classification so that they can then submit that automatically. And I'll stop there.
Thank you for that. Good. So now we have 10 minutes of discussion. We have quite a few questions. We're not really sure if you can see them all, so I'm just going to go ahead and read them through and make sure that everyone gets their questions answered. So let me start with questions. So Larry asked whether the ClinVar API, whether submissions through the API will show up immediately in ClinVar UI, or there would be a whole process to curate them. And the answer is yes, they will be submitted weekly rather than immediately through the API. And I'm sure that's ClinVar ensuring standards. Great. Larry also asked about the ClinVar API, whether we'll use the GA4GH standards around variant annotation, and I would add variant structure. And so Melissa is saying, yes, we are starting to look into that. There's a draft of it. So that's very exciting. I think that's one of the areas where this forum can start connecting closer to GA4GH standards and make sure that they're fitting in both directions. So thanks for pushing those, Larry. There's a question about the ClinVar API. Again, oh, just moved. Great. I'm struggling with this, as you can tell. Whether third parties can integrate into it, and the answer is yes. That's not really ready right now, but it's certainly an important feature, and this is for companies that, for example, provide decision support or variant exploration that are offered to labs. And so the idea is that the application is on behalf of an individual user. So Petros is asking about, yes, ClinVar API, whether you can retrieve data, and the answer is right now, this one is for submission. There are functions to retrieve data from the actual NCBI website, and there is both there if you're interested in the APIs, and an email if you want to ask for further details. I wonder, Melissa, if you want to say something else about that. Seems like an important clarification. One is the variants. I used to have to generate some XML and submit it to you. Now, and then now there's going to be a programmatic API that enables this integration. And the other one is actually I'm a consumer of the data in ClinVar, and I would like to programmatically access that. Anything else you would like to say around that, Melissa?
Yeah, so just to clarify, that's exactly right. We have had a series of APIs for many years called e-utilities. That's what the link is in the question and answer. It's a fairly old set of utilities, so that's why I have the question there that if you've tried e-utilities and they didn't work for you, let us know what's working and what doesn't. The API that we're developing now that I talked about today is only for submission. And so it works a little bit differently than e-utilities. So yeah, if you have any questions about either one, just let us know through email, and we'll help you get it sorted.
All right. And then there was a point about the release, which would be October, November. I'm conscious we're a little bit behind time, so I'm just trying to answer them. There's an important question about the Genomic Health Implementation Forum and whether that's open to all national, so to everyone beyond national initiatives. I would ask Lindsay or Catherine or Angela to answer that. It's a complicated discussion.
Yeah, what we can do is circulate the criteria, but what we're looking at, this was originally national initiatives, but now changed to the implementation form, because recognizing that there are many large-scale initiatives that are either within regions of countries or actually might involve, like H3 Africa, entire continents. So there is a wide variety, but we encourage you to fill in the simple form that details those criteria, but the more the merrier.
Yep. Thank you. And then there's a set of questions on Big Med. I think the Larry, I propose we take those and answer them as we go, just to keep us on time. So please do go ahead and answer them.
Larry should
I think I will go to the last one from Hidewaki, which is, do gene curation teams focus on genes which are related with diseases by GWAS?
So I can say that's.
Go ahead.
Can you hear me?
Yes.
Yeah, great. I would say that's maybe something we would eventually like to focus on. Right now, it's highly penetrant monogenic disease that we're working on.
Great. Okay, I think if that's probably all the time we've got for questions in that session, but thank you, Augusto.
Yeah, I would say it's an important question, because we are separating the problem of or the challenge of dealing with monogenic diseases and really understanding what do we think from a diagnostic point of view when you are liable legally to go to court if you give the wrong diagnosis, versus I have an interesting discovery. I want to see whether some of this hits from GWAS in a patient. So I think it's important when we talk about GNCC and panel labs and so on, it's much more on that diagnostic level, evidence-based. I'm going to go to court for that, versus I'm a researcher. I'm interested in seeing if I discover a new gene, or perhaps work out a family much more deeply because I have the time and the resources. All right. With that last question, I think we should move on to the next session. Thank you very much. Thank you everyone for your attention.
Thanks so much, Augusto, and for all the speakers. And really just to highlight to our audience, we've had some great examples there of how we can share knowledge around gene disease validity, sharing of gene curation resources. They're also great for training our young people coming through. And we're all very excited about the API that's going to allow faster and easier submission into ClinVar. So these are the types of resources that and the types of programs that we'd love you all to become involved with. We're now going to move to talk about consent, dynamic consent and return of results. So I'll hand over to Christina to chair this session.
Thank you very much. Hi, everyone. Good morning, good afternoon, evening, wherever you are. We will be starting the presentation with the consent work that Susan Wallace and myself have been working on. So Justina, I think you can show the first slide. Thank you. And of course, Megan Doerr and Bertha Knoppers are not on the call today, but they are part of our consent work leaders. Next slide, please. I'm going to hand it over now to Susan Wallace for the first part of the presentation.
Thank you very much. And thank you all for today, and thank you for this opportunity to be talking about the consent work that we've been doing. I, along with my co-leads in this work, Megan Doerr, Barth Maria Knoppers, and Christina. And I'm going to do the first bit of this talk, and then we will move to the next, then Christina will take the second part. And Christina, are you controlling the slides?
Christina is, if that's the case.
Or am I? Oh, right. I think I have it. Apologies. Could we go back? Yes, thank you. The consent task force members here are listed. Thank you very much to all of them. And if anyone wishes to be involved in this work, please, we welcome views and the work of people who wish to be involved in this area. The next slide, please. So the work on the harmonization of consent, and when I use the word harmonization here, I don't mean that we're trying to make all consent the same, because that would not be a possibility. Instead, we look at harmonization of consent as trying to harmonize the activities together so that they're following the same ethos under the Global Alliance. And so this has been broken down into 3 parts, with the large-scale initiatives, genomic research consent clauses, and the WGS testing and routine clinical care. Underneath these, we've got familiar consent clauses that are underlying all 3 of these areas. And we thank the RU's support in this. So our deliverable is to be creating generic model clauses to help people to create a direct one-stop resource for the driver projects and national initiatives to use. Could I have the next slide, please? So we've been worried about readability level. We want to make sure that the language that we use on these consent clauses are useful and readable for patients, participants that will be reading them and seeking to understand the information. So we've been working with the Your DNA, Your Say group to align our language with their public data research, so that we are being sensitive to ensure that we're not speaking above people's heads on these kinds of issues, because it's very important, obviously, that we are clear in what we're trying to get across on sometimes complex issues. So the genomic research consent clauses, which is the area that I have been leading on, is this year has been an updated work that was originally conducted in 2015, and over those 5 years there were significant changes in language, in consent forms, etc. And so we updated those clauses. They were formally accepted by the steering committee on the 8th of July, and they're now available as part of the RU's toolkit. And this is an example here of the consent elements. So we structured it so that if you had a participant information sheet or patient information sheet, and the categories of information that you wanted to get across in your information sheet, these are kind of questions we phrase them under, and then created clauses based on models of clauses that had been donated to us from various groups. And thank you to anyone that sent us a consent form to look at, so that we knew that this language was being used. We anonymized it, and so put it together in this hopefully useful resource. The hope eventually is that this kind of generic model work can be used in a machine readable way. There are activities being done that are trying to move this into machine readable consent. And so having generic language hopefully will lead to something that could be used in that group. Well, we certainly hope so. So I'm going to now turn it over to Christina, who's going to talk about the rest of the work of our group.
Thank you, Susan. So I think that most of you remember the presentation that I gave in March, where we discussed the large-scale initiatives consent clauses. That was the part of the work that we were focusing on at the time during our presentation, since it was also the work that we were doing at the time. We're collecting these consent clauses to create a catalog. So now you can see all of the bits and pieces of that broader puzzle that we're trying to solve. So the first part was presented by Susan. The second part is a catalog that was already created. It's now completed. Thank you for everybody who sent their clauses and consent forms. The next step is to achieve the same result as Susan did, which is to have these generic consent clauses as we are identifying trends in these large-scale initiatives consent forms. We named it large-scale initiatives because, as Catherine was also explaining before, there are national initiatives, but there are also sometimes broader intercontinental or very large scale initiatives that are not necessarily controlled by geographic regions. So this is why we have named it this way. And Yes, thank you. Okay, I am controlling it. So, oops, I'm sorry. I was a bit too eager to go to the next slide. So we are also working on clinical consent clauses right now, which is our next step. We also are, so I'm going to go with the familial first, sorry with the slide. Chaotic shuffle. So we are now working on the familial genetic consent clauses, Martha, Maria Knoppers and I. So we have also completed a catalog because we have collected all of these consent forms across all of the categories. We focus on the clauses that were specific to familial obligations or potential impact or involvement on family members in genomic research and even clinical genomics. So we have published a catalog in the last year, and we have now published also a article that you can see the full reference on the screen, where we have put together a typology of all of these obligations from consent forms that we've collected, but also we extended the analysis to countries, political document, policies, guideline, international regulation documents. So we have also analyzed that type of document for the purpose of the typology, and you can find the result of our analysis in that article. The next step is the next step for the large scale initiatives, and the result of the genomic research one is that we are now aiming to draft generic consent clauses for that particular issue of familial consent clauses. Here is the result of a typology. So as you can see, there are 7 categories that we've identified, and these are the ones that you can see in our article. So it creates that kind of spectrum in between a legal duty to communicate in some countries. I think as Spain and France, it's very strict, whereas you have all the way to a usual disclaimer that you can find in consent forms. So all of that data was collected in that article. The next step is the last branch of the whole consent work that we're doing right now is the clinical genetic and genomic consent clauses. So we are still at the stage of collecting these consent forms. So as you can understand, that all of that work started from collection of these consent forms. So we are looking for consent to genetic testing in the clinic forms. So if you have any form that you would like us to include in that analysis, for us, really, the more the merrier. Anything that we could put on our hands on for the analysis would be absolutely amazing. We're really looking for clinical implementation clauses. So really anything that you can think is handy here, we would really appreciate it. You can send it to me at the email address on the screen, so we can start that next step soon. And as you have also understood, the final result would also be generic consent clauses at the end of that collection and analysis of the data. Finally, we will be having a consent workshop next week during the GHIF 8th plenary event. So more specifically on September 28th at 9 a.m. EDT. We will be going through the generic consent clauses that we've drafted following our typology of familial consent clauses, and we will also be kickstarting the clinical consent clauses. So even though we would have not collected all consent forms by then, we have a few which would allow us to start the conversation to see what we really have to include in that last strand of the analysis. So you are more than welcome to join. With the slides that are going to be shared, you will be able to click on the links that are on the slide. And these are the members of the RUS that will be chairing the meetings next week. So thank you very much for your attention, and I will turn on to Anna Lewis and Robert Green for the return of results part of their presentation.
Good morning. This is Robert Green in Boston. Good morning, afternoon, and evening to everyone. Thank you so much for allowing us to give you a brief teaser for a workshop that's coming up. Anna's been doing most of the heavy lifting on this. Anna Lewis is a extremely talented postdoc who's been working with us and diving into this area. And she's going to present a few slides on genomic return of results in research studies. This is stimulated by challenges that Catherine and later Bartha made to us several years ago to see if we could try to bring together and harmonize some sort of policy or understanding between groups around the world in this topic, which has been fast moving and occasionally very diverse opinions. So we tried back then. We had a lot of differences, but things have changed a lot in the last couple of years. So we thought we'd try again, and we'd love to get everyone's input and participation if they are interested. So Anna, take it away.
Thank you, Robert, and thank you, Christine, and everybody else. So, yeah, why a return of results policy? Well, as Robert mentioned, the GA4GH, particularly the Regulatory and Ethics Workstream membership, have been expressing interest in this for several years. And of course, GHIF projects bring together, a wide range of international experience of returning results of research studies, which we'd like to take advantage of. And why now? Well, as we know, there's an international patchwork of ethical and legal positions that support return of research results in research settings. And as Robert was alluding to, over what's really changed in the last few years, we've got a broad international trend towards more participant engagement in research. And there's also, as we've been hearing, widely available tools that have lowered the resources needed for projects to implement return of results policies. And of course, no one project is equivalent or identical to another. Context really matters. And what would be decided on to be reported is ultimately a project-specific question, depending on all sorts of factors, perhaps most notably the health system in which the study is interacting with. But we believe that although the exact content of what gets returned will vary between projects, some things are in common across the board, and that includes the logic that supports the return of results policy. And we think many of the best practices for implementing such a return. So again, as Robert mentioned, this presentation is really just a teaser for a workshop that we're holding this coming Monday in the same time slot. And yeah, this is to invite anybody to come and engage with us. We'd love to have multiple views represented. And in this workshop, we're going to have the legal landscape covered by Adrian, who will be a familiar face to many of you. And as part of the GA4GH WERS group, Madeline Mertag, Dania Viz, and many others have been involved in a massive review of stakeholder views on return of results policies in research, and one of them will be giving us an overview of that. And then we're going to have a panel on project experiences, again with some familiar faces from 3 of the different national initiatives: Chris Patch, Clara Gaff, and Kate Blazinski. And really the meat of the workshop is going to be a discussion on a draft aspirational policy, which I'll bring up in a second. And what we're looking for is a very robust discussion around that, and also some alignment on what it will be most useful to include alongside a draft aspirational policy by way of pooling of expertise and what we can sort of distill from the collective experience of many of the projects, as well as aligning on next steps. So date for your diary, and at the end I'll show my email, and please do email me if you're interested in coming, and we'll make sure that you get on the list. Okay, and I'm sorry, I'm probably just going to read this out loud. I don't know how else to do this, but this is our starting point. So any research study that provides genomic sequencing of human beings should budget for and implement a return of results policy to look for and offer to return at least a minimum list of actionable genomic findings subject to participant consent. If resources within the research enterprise of the surrounding healthcare system are such that this is not achievable, there should be a clear statement as part of the consent that resources are not available, but that returnable findings will be identified and returned if resources become available. So that's a starting point, and as mentioned, we're really looking forward to the discussion around that, and we'll see where we end up. Yeah, so there's plenty of work to be done. This work is at a much earlier stage than the work that Christina and Susan were just outlining. So please come and get involved at this early stage. We want to iterate on this aspirational policy and yeah, decide what will be helpful to synthesize alongside that. And our goal is to have some sort of draft document by January. So yeah, workshop this coming Monday. That's my email. Would love to hear from you. Thank you very much.
Thank you, Anna. So I'm going to pass along to Bobby Ray for the next part of the presentation, which will be show and tell on NACG, so the Nordic Alliance for Clinical Genomics.
Hi. You have my slides? Someone has my slides available. There we go. Okay, hello everyone. I'm happy to share a project by the Nordic Alliance for Clinical Genomics. This project is about developing a harmonized approach across the Nordic countries to consent for genetic testing, both within the documents that are used, but also for its process. So who are we? NACG is an independent, non-governmental, not-for-profit Nordic association. And for more information, we do have a webpage at nordicclinicalgenomics.org. So essentially, the pan-Nordic clinical consent framework will produce three things. This will be an adult information packet, an adult consent form, and guidance to the process for delivering consent. And a couple of factors have motivated us to do this work. The first is that we are considered to be the leading precision medicine initiative in the Nordics. We feel well positioned due to this to influence widespread adoption of a harmonized clinical consent practices across the Nordic countries for genetic testing. And we believe that the adoption of such a framework may contribute to and accelerate genomic data sharing initiatives across the Nordic countries. The framework is being developed by professionals and stakeholders across the clinical genetic testing value chain. This has representation across all the Nordic countries and includes about 5 main stakeholder categories, of which the majority are NACG members. Among these categories, we have the Nordic PerMed Law Group. This is a network consisting of legal representatives across the Nordic countries. We of course have healthcare institutions from each country, also with representation of the largest healthcare institutions in the Nordic countries. For example, we have Oslo University Hospital, Karolinska University Hospital in Sweden, Rigshospitalet in Denmark. And we also have the professionals that sit within those hospitals that are very interested in adopting and implementing this framework, from genetic counselors, healthcare professionals, healthcare leaders, bioinformaticians. We also have a patient group representation to ensure the patient perspective is integrated into the framework. We have governmental organizations such as the Danish National Genome Center, and industry is involved, such as ourselves, and where I work at DMVGL is involved due to the interest of looking and developing roles that can better enable a safe and secure implementation of consent. Can I have the next slide, please? Just a little bit about the development. The development of this framework started at the end of 2019 and has since consisted of multiple activities, really to ensure that these consent documents that we produce are subsequently used and of high value to the users. Amongst these activities, we've had mapping of policies, for example, within GA4GH, also sitting within country-specific policies, legislations, best practices. We have had multidisciplinary workshops, we've conducted surveys, and we've had different types of stakeholder reviews to the documents. The development has required many pivots along the way, and this is really due to legal clarifications, alignment on clinical needs, also patient needs. And what we found so far is that the process has had immense value, not only for developing this consent framework, but also the work has provided a sort of platform for these stakeholders across the Nordic countries to align on these topics about consent. For example, how to best harmonize consent practices that promote data sharing. In terms of the next steps, we have a multidisciplinary workshop approaching in November. And once all the input has been received from this workshop, we will publish the final consent documents on our webpage that will be downloadable and adaptable to hospital settings. The hope is to have these forms available in all the Nordic languages. After this is available, we plan to make continuous improvements to the documents as we get feedback along the way. We're looking at implications that would be beyond the Nordic borders. I sit within the GA4GH group to discuss the consent framework there, looking at synergies there. Also looking at the possibility of implications to having a focus more on a harmonized consent approach in research. One of the findings that have stuck out consistently in this process is that there has been a real need for not only a digital, but as we're presenting today, a dynamic solution for consent management. And this is where industry partners like ourselves are interested in developing and promoting roles that would promote the trust and secure solutions in a digital dynamic solutions. We have information to our workshop in November is on our webpage. You can see it there, nordicclinicalgenomics.org. We also have two forms, the consent form and the information packet in draft version, open for comment on the webpage. And anyone is welcome to go on that webpage and have a look, and please send us any comments or feedback that you have. Thank you.
Thank you, Bobby. So now the last part of the presentation will be given by Alice Matimba from H3 Africa.
Alice, you're on mute.
Thank you. Hi, everyone. So thank you for giving us a few minutes to talk about the a tool that we've developed with the H3 Africa Ethics Working Group. So we have developed a tool for return of individual genetic results. And so for those of you who might not be aware of H3 Africa, so this is a large consortium of researchers on who are studying African human genomics. And the program is funded by the NIH and Wellcome. It is the largest human genomics consortium in Africa with up to about 51 projects that are supported. So being such a large consortium, obviously quite a number of working groups that have been formed, and the ethics and regulatory ethics working group has been tasked to develop recommendations and guidelines on various issues around ethics and regulatory issues, which are required by the consortium. So the working group have developed quite a number of resources, including ethics framework for genomics and biobanking, and for consent resources as well. And you can go to h3africa.org to find these documents. So as for, as researchers have been generating quite a lot of data, and some of it might be of health relevance. So some researchers had requested to find out what's the best practice in giving that information back to participants. So we developed a framework, a decision framework, considering feedback of individual genetic results as a tool, rather as a guide for research projects that are considering giving back feedback to their participants. Next slide. How do I go? How do I go to the next slide? Okay, thank you. So having sort of initially, so we kind of like outlined all the general, all the general consensus for feedback of genetic results, from previously published work and other, consortia around the world. And obviously considering things like, we should be giving back findings that are of health relevance or of use to the participants. They have to be accurate, reliable, and they have to be validated and so forth. But we also flagged some of the contextual issues in African research and on African regions, such as people not having inadequate resources, for example, to actually do any validation, having sparse African data. So, again, to validate some of the, results. Limited expertise and also limited evidence base about what participants or what research participants would prefer, if they prefer to get their results back or not, and taking that into consideration. So this was some of the limitations that were flagged. So anyway, we did go ahead to develop at least a framework to start thinking about the considerations that research projects and researchers should put in place. And so we just drafted some of the primary conditions for feedback, some of the issues around determining pathogenicity, clinical validity. And so we developed a feedback decision pathway, which takes into consideration all these things. Next slide, please. So this is the decision framework that we developed. And so it starts with researchers thinking about whether they want to incorporate feedback in their research projects and what plans they should put in place. So this includes thinking about either developing a protocol, for example, a policy or within the protocol. A lot of the projects that are running in H3 Africa are multi-center, multi-country projects. And so it would be good to think about putting together something that will be consistently used across the different sites. And then the research team obviously should think about what expertise or clinical expertise or analytical expertise that would need, and in order to be able to assess, the various things like evidence of pathogenicity, clinical value, and validity, and so forth. And also to think about, the capacity to be able to, to feedback during the feedback process, including funding, health service provision, and so forth. And as I mentioned earlier, it's also important to align the different policies in the different countries or different sites to make sure that the ethics review are aware of, what the research participants will be receiving, and what would be the best way to provide that, that service in the different countries. So while thinking about evidence for pathogenicity and clinical validities, we also noted that there are obviously quite a lot of gaps in terms of African genomics data. But of course, this is slowly improving as there's more data that's coming up and more clinical studies that are being run on the continent. Were also suggestions to take advantage of some of the resources that are already been developed. So some of the data sets or databases that have been developed to help researchers to determine, pathogenicity, which will be relevant to African populations. And then when deciding to feedback findings, researchers would then also need to, to decide, explain how these research could be of clinical utility and taking into consideration medical actionability. So with clinical utility, in our case, obviously there has to be a strong prediction for an adverse clinical outcome. It is of high clinical utility, but provided there is also guidance on a possible intervention. And we are also aware that this could also be a challenge, where in some countries, actionability in different countries, actionability probably means different things depending on the resources that are available, medications that are available in the different places. So these are some of the things that the researchers would have to think about as they are deciding whether to go ahead and develop a feedback process or not. And then when it comes to the feedback process itself, participants need to have consented, and they need to have consented to be recontacted in this case. So this should have happened earlier on. And then the findings themselves would have to be verified. And we suggested different ways of verifying, these results. Again, there are going to be resource challenges there. And finally, the genetic counseling services. So a lot of African countries do not necessarily have dedicated genetic counseling services. So suggestions would be, do we have clinicians or health professionals that may be trained to feed back some of that information? Of course, this should be working together with, with the health professionals organizations to make sure that we will be able to build capacity in this field for genetic counseling in the countries where they do not have this. So part of this, this policy also touched a little bit on other situations where, there may be incidental findings for conditions that are quite more prevalent, such as sickle cell disease and so forth. Would you, if you are studying a population where you know that this highly prevalent marker, which you may find in your research, what would you do about it? So we do touch a little bit on how to feed back incidental findings of that nature. Yeah, we also touched on the incorporating familial issues and cultural issues. So would you, when you're feeding back, consider that you may have to do family feedback, and we also provide some guidance on that process as well. So in summary, we came up with this framework to feedback results that are pertinent to the research or regional research project, and assess for for pathogenicity, clinical validity, utility, and the policies that would be developed across the consortia should be the same across all the different research project sites, and that decisions to feedback have to be approved by the research ethics committees, and again, only feedback results that have been verified, and participants have to have consented that they would like to get results fed back to them. So that's it from us. Welcome any questions, and feel free to let us know if you need any documents or resources. Thank you.
Thank you, Alice. So I think that for the sake of time, we will be opening up the question and discussion period for about 5 minutes. So I see that there are no questions yet in the Q&A section. We can always answer them throughout the rest of the presentation through chat or the Q&A. But if anybody wants to address something right now, you have a bit of time to do so.
This is Robert. I have a question for Alice, actually. Alice, so much of what is in that wonderful slide that you showed, I guess, depends on your definition of, for example, yes, no, whether you have personal utility, yes, no, whether you have clinical utility. Has the work that you're doing started to define what criteria would be used to say yes, no to those questions?
Well, I would say yes and no. There are some projects that are working on developing more guidance specific for their projects. So, for example, I think the conditions such as sickle cell disease are quite well established, and some of these would be easy to to demonstrate these kinds of things, and other monogenic diseases. So to say whether we're starting to see how this works, this is part of the next steps, which is to see how well this can be applied across other projects and other conditions that are like the complex diseases that probably have a bit more complexity in figuring out what is really useful for the research participants.
Thank you.
Now, in the interest of time, I think we need to move on to the next session. So thank you, Christina, and thank you to all of the speakers, and make sure people are considering attending the fascinating workshop on return of results on Monday. So give Anna a shout if you wish to do so. So our final session in this first part of GIF, we'll all be back tomorrow night as well, or tomorrow morning, is on clinical data capture and exchange. And I'll hand over to David Hanson to share this session.
Great. Hello, everyone. And again, good morning, good afternoon, good evening, wherever in the world you are. And I hope everyone's well and keeping safe. So to start, okay. So I believe I'm controlling the screen, but you might need to help me, Lindsay. Anyway, so today we've got 3 short talks and then some questions and answers. We'll see if we can get underway quickly and still finish on time. So first up, look, it's been great working with Melissa and Lindsay and other people in the clinical and phenotype data capture workstream. So the first, for the first 10 or 15 minutes, Melissa and I will give you an overview of the clinical and phenotype data capture workstream before we have a talk from Kenjiro from Japan. So I'll hand over to Melissa to start giving a talk about giving an overview of the clinical and phenotype data capture workstream. Over to you, Melissa.
Terrific. Good morning to those of you in this part of the world. It's very early. So I think what we'd like to start off with was just a few questions for you all to put in the back of your mind so that we can, as we go through the talks this morning, you can have an idea of how can the clinical and phenotypic workstream help facilitate the work that you all are doing in the national initiatives. So specifically, what are your clinical and phenotypic data capture and exchange needs, and how can we improve the standards that we have for capture and exchange for use in the clinic? So next slide. So clinical and phenotypic data actually exists in many different forms. We have survey instrument data, we have laboratory measurement data, we have qualitative deep phenotyping data, we have imaging data, we have omics multimodal data. There are many different data modalities to consider. But all of them depend upon their use in clinical care, all depends upon this virtuous cycle between patient encounters and medical knowledge. Specifically, those phenotypic data make their way from the patient in whatever setting into clinical databases and repositories and registries, where we can then infer information about medical knowledge worldwide. We can manage that knowledge, we can encode it, we can classify it, we can keep it up to date. And that knowledge as it accumulates leads to clinical guidelines, which then lead to expert systems and decision support and hopefully improved patient care. All of this cycle for any kind of clinical or phenotypic data depends upon a robust suite of data models and terminologies that help support the movement of that clinical and phenotypic data. And so this is really foundational for us to create a learning healthcare system in genomic health. Next slide. So this is just a couple examples. Again, we don't have enough time to go through all the different data modalities, but from our own work in the Monarch Initiative, where we work a lot on semantic phenotyping and deep phenotyping for describing patients' clinical features to help aid diagnostics, especially in rare disease. This example is a patient described, a 3-year-old girl on the left and a 14-year-old boy on the right. They both came into the same clinic within a few weeks of each other, but were very challenged even with expert diagnosticians in receiving a diagnosis. The combination of whole exome sequencing and deep phenotyping is described with the human phenotype ontology shown in the green on the left and orange on the right, was able to actually diagnose both of these patients, which are somewhat similar but somewhat dissimilar, as having different variants in the KMT2A gene and having Wiedemann-Steiner syndrome. And you can see how those phenotypic features and using the semantic comparison algorithms can really help facilitate that type of diagnosis, where the standard definition for Weidemann-Steiner might include a long toe, whereas the 3-year-old girl might not have a toe phenotype. And so using this type of approach, it's very useful to help support rare disease diagnostics where we simply don't have a lot of examples worldwide for patients with rare diseases. And so being able to match in this way has really been enormously useful for diagnostics. Next slide. So this is just an overview of how this works in the context of combining that phenotypic data with whole exome or whole genome sequence data, and the use of the HPO over there on the right in combination with that knowledge that I referenced from OMIM, Orphanet, the Human Phenotype Ontology, but also from more basic science resources such as StringDB, where we have protein-protein interactions, and model organism databases can all be combined to help prioritize variants for that patient. And this is a tool called Exomizer, and there's a link there if you're interested. It's been used in Genomics England and around the world, and is a ERDIC recommended resource for rare disease diagnostics. Next slide. This is just an example from Genomics England, kind of showing how that works. This is a patient, Jessica, who has over 6 million variants, with 677,000 of them being rare, 2,800 predicted to cause a change in the protein, and 67 different from her parents. And using this type of deep phenotyping approach in combination with the whole genome sequencing, the Exomizer tool is able to rank the correct gene. The wonderful thing about this family is that Jessica has a rare condition which causes epilepsy and was causing developmental delay, but her condition is successfully treated with a simple dietary ketogenic low-carb diet. And so it really sort of hits home the point of why we need early intervention and early diagnostics, and to use all the data that we have in hand in order to help support diagnostics. Next slide. So how can we actually get more data about these individual patients? Well, we have encodings for genes. We have HGVS, we have simple ACTG. For phenotypes, we have encodings such as the Loink laboratory terminology. We have the NCI thesaurus for cancer. We have the Human Phenotype Ontology for the phenotypes as I described. And these computable encodings for phenotypic features are just as essential for global sharing in clinical genomics as the sequence information. Next slide. The challenge is that we don't actually have, or we didn't until recently, a way in which to exchange case level phenotypic information that was not free text. So we have exchange mechanisms for sequence information, VCF files, bed files, et cetera, but we didn't yet actually have a computable encoding for phenotypic information to exchange information about individual cases. And as I mentioned, it's really difficult to build these systems for diagnostics when we simply don't have a lot of phenotypic characterization of the individual patients. So PhenoPackets was developed in order to help support this use case. Next slide. So PhenoPackets, so traditionally what ends up getting sent to a clinical lab in the context of a patient like Jessica is either a dump of the full EHR, if that's allowable, or a candidate diagnosis and not a whole lot in between. And so we really want to help support this sort of intermediate sharing of information about the phenotypic features that can describe how are those features linked to the patient, to the genomic information, to samples, to the parents and siblings via PED file or our new pedigree standard that you'll hear about from David. How severe are these phenotypic features? Are some more severe than others? When were they first observed? Were they not observed? And sort of coming up with a computable encoding for exchanging this case level information. Next slide. So this is just a quick example, creating a unique identifier that's de-identified for any individual, having a link to the association of the genomic information. And then over on the right, just an example of showing what the phenotypic features look like in their basic encoding of which phenotypic feature with its identifier and its label, the severity, the age of onset, and there are many other attributes that are available within the PhenoPackets standard And one of the important things here is that the use of ontologies to describe phenotypic features in any ontology can be utilized in this context. But the use of ontologies allows that fuzzy phenotype matching as well as search and discovery, because you can use the underlying logic of the ontology to identify patients that may have a more general or a more granular set of phenotypic features. Next slide. So this is just an example of who are all the different types of users for phenopackets and what are the use cases. So I already mentioned the example of the clinical lab, but we also aim to help patients themselves generate phenopackets for sharing on the web. A lot of rare disease patients actually aid in their own diagnosis by sharing their own information on Facebook and other places. We'd like to help them do that better by using the computable phenopackets structure. The human phenotype ontology has actually been translated into layperson for use by patients. So that's one key use case. We also are really interested in supporting patient registries so that we can get a better understanding of the natural history of rare disease patients. We are working a lot on the cancer phenopackets, so this would also be useful for cancer registries in the future. Another really important target for phenopackets is journals. Oftentimes in journals, we have these tables of patients that tell you the percent of patients that have any given phenotype, but not individual information about which phenotypic features each individual patient collectively has. And so we don't really have the co-occurrence information that we'd like to have for our diagnostic tools. And so having a more robust representation of phenotypic features at an individual level is really, really important for genomic medicine and how we publish our information. And then finally, being able to leverage phenopackets in the context of registries and databases and web tools and algorithms so that we can actually operate on genomic health data at an individual level in a de-identified and publicly shareable manner. Next slide. So this is just a lovely example from AMED, one of our driver projects in GA4GH, and they've implemented phenopackets for their biobank network. And so this is just an example of how you can essentially get a phenopacket associated with each of their biospecimens in the biobank. Next slide. So we need more than simply these phenotypic features. I mentioned I've only been talking about the semantic deep phenotyping, but there's many other kinds of phenotypic information that can be associated within a phenopacket or otherwise exchanged. And so we are working on a variety of different efforts to help support more of an integrated interpretation packet, if you will. So working on enhanced pedigree information, which you'll hear about from David in a second, which is also being coordinated with HL7 FHIR. Working closely with the genomic knowledge standards work stream, working on how we represent variants and annotation standards for genomic variants and interpretations that go alongside the phenotypic information. And then jointly working on a new standard for representing treatment course and therapeutic responses is really a phenotypic information, especially important in cancer, but important for all genomic health. So these are essentially the minimal needs that one would want to have for genomic interpretation at the level of an individual in a de-identified manner across systems. It's by no means sufficient, but this is our goal for sort of minimal implementation. Next slide. So what about the EHR? So EHR the electronic health record encodes billing and encounters, but does not provide the deep phenotyping that we actually need for genomic interpretation. And so we really need to figure out better ways of supporting more robust phenotypic capture and inclusion, both pushing it into the EHR as well as getting it out of the EHR. Next slide. So the workstream has a goal of working on a phenopackets FHIR implementation guide. So working with HL7 FHIR to help support EHR interoperability with the overall goal of increasing the availability of standardized phenotypic information for genomic research and genomic medicine, as I mentioned, both into and out of the EHR. Next slide. And so this is where GA4GH can really help FHIR. So FHIR functions on having content models that need to basically be put into the containers. And there are many clinically relevant data types that different people are working on aligning with FHIR, a few of which are being developed within the context of our work stream. So one is the FHIR phenopackets that I mentioned, but our pedigree standard is also aiming to support robust representation within FHIR. Also relevant to this community here are the clinical research variables or common data elements, which are needed by most organizations doing large cohort work, as well as genomic and other data, geospatial and social determinants of health, survey instrument data, and many other different kinds of data modalities essentially need the modeling and the sort of standards that can then be put into the FHIR containers, which are the exchange mechanism for pushing things into and out of the EHR. Next slide. So I'm going to hand this now off to David to talk about our pedigree standard work and also give you a sense of what the workstream is working on next. Thanks very much.
Great, thanks, Melissa. So Melissa was talking there about the work we're doing with phenopackets and describing a phenotype. That's one of our projects. Another of our projects is the work that Grant Wood and Orion Busk, I think I got that wrong, but that's Orion, are doing with the pedigree standard. And so this is all about how we represent and capture family history and how that gets used in analysis of that information. So the first step was to understand the problem, and earlier this year we did a survey of our driver projects, and and I'm sure there's some people on the line who participated in the survey, so thank you very much for that. And so we had over 50% of people acknowledge that they're experiencing problems with how the pedigree information about their patients was being captured and how they were using that, that information. And the examples given were things like hand-drawn pedigrees, lack of computability, just plain PDFs rather than being able to do anything with it, representation of complex families, and inability to share data easily. So a bunch of problems that people recognised in dealing with this sort of data. Next slide, please. There is some standardization at the moment, and the PED file or the PED format is what most of people are using at the moment. But people still reported that the PED file didn't support everything that they wanted. It captured the basic parent-child information really well, but there was lots of information which it didn't actually capture. Next slide, please. So what's really important now is that Orion, Grant and the team have come up with a first set of key requirements that, that we'll be looking to have in a first version of the GA4GH pedigree standard. And this will be discussed next week in plenary. We've got a meeting where we hope to finalise that first version, ready to take through for approval in the new, later this year through the GA4GH process. So that standard will include the superset of columns already in the PED format, optional genderless relationship vocabulary for distinguishing biological and social relationships. We want to represent a set of minimal core family health history data elements, including most of the National Society for Genetic Counselling nomenclature guidelines. We want to represent provenance of family history claims. We're going to do this, as Melissa mentioned, within the context of other standards, including FHIR, and we want to have the ability to convert the family history from one proband to another. And so these are the requirements which have come out of a lot of discussion around how people want to capture and use pedigree information and the problems with the way that it's done at the moment. So already, you know, I think everyone's learned a lot from just being involved in this discussion. Next slide, please. So we have already what we tried to do in the work stream is to not just come up with the standards, but we want to test the standards and work with driver projects. So we already have collection tools for the pedigree, and the same way that we do for phenotype data. And so want to mention in particular Phenotips, which was Orion's product out of Canada, the Monarch Initiative, and some of how they capture information. And then Catherine mentioned earlier that the Australian Genomics have implemented a pedigree drawing tool within REDCap, and it's the same drawing tool which Phenotips use, and so we'll be able to exchange information, and we'll both Phenotips and our REDCap tool will continue to upgrade the data capture mechanism as we implement the new standard. So so that's available for everyone either through those software mechanisms. Next slide, please. So they're the products and projects which we've got underway: Phenopackets on Fire, and the pedigree drawing tool. Next week at plenary, we'll also be discussing how we represent cohorts. It's an important point in genomics research and clinical care, is how we actually cohort patients. So that will be a new project we'll look to get underway, starting with meetings next week at plenary. And we'd love to have everyone involved in all of these projects. So we look forward to hearing from you in the future, or at plenary, of course. Just, I think two more slides. So next slide. As I mentioned, next week at plenary, we'll be discussing computable cohort representation, extending Phenopackets. We'll continue to focus on adoption and implementation, and this work stream does work across standards development organisations, including ISO and FHIR. And next slide, the work stream does, apologies for the noise in the background, the work stream does have monthly full work stream calls, bi-weekly Phenopackets and pedigree subgroup calls, as well as a GitHub space and a Slack space. So I'll finish there, and just to finish up, I hope everyone can stay around an extra 5 or 10 minutes now, and I'll hand over to Kanjiro to talk about how they have developed their a patient archive localization. So over to you, Dr. Kanjiro.
Hello. Can I have the first slide, please? Before talking about the phenotype capture, I'd like to briefly introduce our national activities that's been facilitated by participation to GA4GH. As Melissa mentioned, the variant filtering is the initial step before phenotype analysis. And we have now nationally coordinated efforts to integrate all the variants resources from normal population standards, as well as from the pathogenic variant standpoint. And can I have the second slide, please? So GEM Japan, which stands for Genome Medical Alliance Japan, has facilitated integration of biobank derived whole genome data. And we have now about 7,600 whole genome data, which is readily available for rare disease research because the variant frequency is now freely available. Can I have the second, next slides, please? And the MGen database, which is the equivalent of ClinVar in the United States, now integrates data from rare diseases, cancer research, and the infectious diseases research, and the dementia researches. And it's now integrated into a single database called MGen, and it's freely accessible from the public as well. Can I have the next slide, please? And now this MGen database is under reform. We are now dividing the database into monogenic section and a polygenic section, so that the common disease can be appropriately dealt with as well. And the monogenic section is now going to be run by the government directly, so that genome data will be implemented in daily clinical activities. Can I have the next slide, please? Now I'd like to talk about the phenotype capture portion. Can I have the next slide, please? We are running an undiagnosed disease network program in our country, and about 400 hospitals are participating. Patients who are not diagnosed by those local hospitals will be referred to university hospitals, which is scattered all over the country. And the phenotyping and exome or whole genome analysis is performed there. And the genome data is sent to 5 genome centers, and the variant will be reinterpreted at the clinical sites, and the result will be sent back. And of course, the deep phenotyping at the clinical centers are the crucial part of this whole cycle. Can I have the next slide, please? And currently, more than 5,000 participants have been enrolled, and the diagnosed rate has been 43%. And the 37 new disorders have been established, and there are more to be discovered, I think. Can I have the next slide, please? And to exchange the phenotype data, we use the patient archive system, which was originally developed in the Australian group, Dr. Tudor Groza. And we have implemented this system into our local environment. Can I have the next slide, please? To briefly introduce this system, the system allows us to type in the medical records directly onto the computer interface, and the HPO terms will be automatically generated as shown on the slide. But the important, more difficult part of this system is that anyone who are fluent in English can use this system in a very convenient fashion, but a country like Japan, where not all the coordinators are fluent in English, cannot use this system. So we have planned to translate the whole system into a Japanese language. Can I have the next slide, please? So I think the key to the globalization of the GA4GH activity partly needs to be helped by this kind of translational effort, I think, and our experience hopefully will help such countries. Can I have the next slide, please? So in Japanese language, microcephaly or ptosis or other medical terms will be spelled like this. And we need to convert this to HPO terms as shown on the right side of the slide. So one of the group has made an excessive effort to translate and make a huge HPO table that is written in Japanese, and that's been very helpful. Can I have the next slide, please? And such table has been used in several systems that are in compliance with many of the GA4GH rules. Can I have the next slide, please? In the IRAD exchange system, which is the local Japanese localized system of the patient archive, now use the Japanese language as a sort of a covering of the English system. We can now type in the Japanese medical terms directly onto the system, and still we can get the regular HPO terms as shown on the slide. Can I have the next slide, please? And by using this system, we can directly exchange the patient clinical information with the matchmaker exchange system. And after the translation of the interfaces and the HPO languages, I think the utilization of the system really improved. And I think this may be a good lesson for other non-English speaking countries. Can I have the next slide, please? Thank you so much for your attention.
Okay, thank you very much. That was great, and great to see the Japanese translation there of HPO. Okay, does anyone have any questions? At the moment, we don't have any open in the Q&A.
I do see that, Nathan, you have your hand raised. I'm going to allow you to talk if you'd like to make a verbal question. You should be able to unmute.
Not happening.
Not happening. We are over time anyway, Catherine, so I might hand back to you to finish up for today.
Great, thanks so much, David. And what an amazing series of talks in terms of clinical data capture. And I think I'm particularly excited by those talks because we're all quite challenged in how we're capturing our clinical data and partnering it with genotypes. And phenopackets, the pedigree standards, are going such a long way to solve that problem for us. And I think, Kenjiro, in your talk, what a great model of how to apply translation into the standards so that they're much more widely used. And I could see Melissa Handel getting quite excited in terms of what you've achieved in that area. And it is certainly something that we need to look at and using you as a model across a whole different range of countries. So I'm going to bring tonight's session, or today's session, it's 11 p.m. down here in Melbourne. For tonight, we have another 2 hours tomorrow with a focus on our quality control of data, what's happening in pharmacogenomics, and then at the end, a really great session where we show how you can pull together all the different standards that are being developed, whether it's from consent to clinical data capture to gene and variant curation, and right to the generation of reports and then reuse of information, and how we're starting to bring that all together. So I look forward to seeing you tomorrow night. Mark and I will be here again chairing the show. And I'd like to also say you've been sent out as part of your registration. There's a half-hour video there that just gives you a high-level overview of all the Global Alliance standards, which is great as background for so many of these talks. And also a link into the form to fill out around formally joining GHIF. What we will have at the end of tomorrow is a good bit of time just to get a bit of feedback on what the people that are attending would find useful going forward. We certainly intend to have regular webinars, but also giving you the opportunity in follow-up to these meetings about participating and joining some of the pilots that we're currently running. Of course, I wish we could all be together in person. I think these webinars work fantastically, and everyone is becoming a lot more adept at controlling the technology. But I was just saying to Mark Caulfield earlier on, I'm really looking forward where we can finish a great session such as we've had today or this evening, and go off and have a couple of drinks together. So I'm really looking forward to when that happens. So same time tomorrow, be there, be part of the crowd. And thank you again to all the amazing speakers that we've had in this session. Farewell, everyone. See you tomorrow.
Thanks, everyone.
Thank you.